Okay, we're going to go through the steps of the soil nitrate quick test, assuming that you have a representative soil sample for the field that you have in question. We just took that off. We've got the sample bulked, and we've got it mixed here, and we're going to put it into 3 parts water to 1 part soil. And we did this volumetrically by measuring 300 milliliters, and this is to 400 milliliters. You could do this just if it's a cylinder like this, you could just do it with a tape measure as well if you don't have a cylinder on hand. So basically, the important thing is that volumetrically you have 3 parts of water to 1 part of soil. So we're going to do that now. Trying to be careful to not put all the soil in from one part of the bucket. We want to get it as representative of the field as we can. So we're just taking little bits from the bucket and mixing it around. So we're getting a good representative sample of the profile from 0 to 12 inches. And samples from all dozen locations that we took in this field. And after we kind of gradually get it filled up to that top line, okay, so now that we have the 3-to-1 water to soil, we also set a timer over here for 3 minutes. And you really do want to set a timer because it's harder than you might think to shake a bottle like this for 3 minutes. I'm always thinking I'm done in 2 minutes. So we set a timer, we're going to shake this for 3 minutes. And because compared to other quick tests, we've eliminated the calcium chloride as a flocculant, it is important that you shake this for a long time so you make sure you get things dispersed. So we're going to do this for 3 minutes, and then the next stage will be testing the nitrate concentration, and we'll show you that in the next video. So now that we've shaken our sample for 3 minutes, and we've got it nice and dispersed, we're going to use our test strip. And the important thing to be aware of is that these aren't all reported in the same units. This is reporting total nitrate as nitrogen. Sometimes it's reported just as nitrate. It's important to know which unit you're in and convert appropriately. So everything we're talking about is going to be as N, so nitrate N concentrations. The bottom of this is nitrate. We're not paying attention to this. This strip is for the nitrate, so we're just paying attention to the nitrate, which is this top strip. And we're going to dip it in, wick it, and compare it to the colors after it develops on the sample. Okay, so some tests, quick tests, ask for you to wait for this to settle, but we are just wicking it, so we're just tilting the solution over and getting enough of that strip in there that it just starts to wick up the solution. Because if we stick it all the way in there, it's going to obscure the color. So we're waiting for it to wick, and it's probably hard to see on the camera, but with your naked eye you can start to see it moving up the strip. When there's nitrate in there, it starts to turn colors at this point too. But this soil looks like it's going to be low in nitrate because as the liquid is wicking up the pad, the color's not changing really at all. So we'll let it finish wicking, and then you're supposed to let it develop for 60 seconds. This wicking process usually takes about 30 seconds, so then we'll let it develop for another 30 seconds after that, and then we'll compare it to the color on the bottle. So now we've let the strip develop, and what we're seeing is that the sample that we took has a very low nitrate nitrogen concentration, looking like kind of trace amounts at 0.5 ppm. So for our tillering to jointing top dress application, this would be well below the threshold that we've developed. Comparing this quick test to a soil lab test for nitrate nitrogen on dry soil, the conversion factor is about 2. So this would be well below the 20 ppm nitrate N on a dry soil sample that would indicate more minimal response. And so we would expect a pretty strong response to a tillering application of nitrogen fertilizer at this field.